Everyone, today we will be discussing the remaining problems of exercise 13.1 of chapter number 13, limits and derivatives. So let's start with question number 23, which is find limit x tends to 0 f of x and limit x tends to 1 f of x, where f of x is given to be, it has two values, that is when x is less than or equal to 0 you have 2x plus 3, and when x is greater than 0 you have 3 into x plus 1. You need to find out the limit when x tends to 0 as well as limit when x tends to 1. So let's start with finding out what is limit x tends to 0 f of x. Okay, so for that again we need to find out the left hand limit and right hand limit. So LHL will be limit x tends to, the notation is 0 minus f of x, and what is the meaning? It is from the left side of 0. So the which value for the function we will choose? Less than 0. When x is less than 0, the function value is 2x plus 3. So replacing the value, you will get limit x tends to, now I am not substituting that negative because I am just replacing the corresponding value of f of x when x is less than 0. So you will have 2x plus 3 here instead of f of x. Now replace the value of x with 0 so that you will get 2 into 0 plus 3, which is equal to 3. So this is the left hand limit. Now finding out the right hand limit, you have limit x tends to 0 plus f of x, which is equal to limit x tends to, again 0 I am writing, and correspondingly what value I need to replace for f of x? It is x greater than 0. So you have 3 into x plus 1. Again replace x with 0 so that you will get 3 into 0 plus 1, which is again 3. So you can see that left hand limit as well as right hand limit are equal. Therefore we will say that the limit exists and it will be equal to limit x tends to 0 f of x, and the value will be what you have got for the both the left hand and right hand limits, which is 3. So this is the answer for limit x tends to 0 f of x, which is 3. Now moving on to the second one, that is limit x tends to 1 f of x. Limit x tends to 1 f of x, again we are checking for left and right limit, but the thing which you have to see is the function's value is not varying about x equal to 1, that means less than 1 and greater than 1, both should be here only. Both the values which are from the left side of 1 and from the right side of 1, they are actually greater than 0. So you will have only one function for both the right hand and left hand in this case. Okay, so LHL will be limit x tends to 1 minus f of x, but the function which you are replacing will be greater than 0, that is 3 into x plus 1. Now replace the value of x with 1 so that you will get 3 into 1 plus 1, 3 into 2, which is 6. And right hand limit will be limit x tends to 1 plus f of x. Again 1 plus is also greater than 0 and 1 minus is also greater than 0. You can just see this is 1. Greater than 0 means all these values, right? And we are taking a neighborhood so that it is a little bit closer to 1 which is to the left and closer to 1 which is to the right. So both are greater than 0. That's why we are replacing with the same function value. That is 3 into x plus 1. Again we will replace with 1 for the value of x so that you will get the function value as 6. That is limit x tends to 1 f of x. For the right hand limit also is 6. Therefore you can say you are getting limit x tends to 1 minus f of x and limit x tends to 1 plus f of x. Both have the equal value. That means limit exists here at the point x equal to 1, or limit x tends to 1 f of x exists, and that will be 6 only. Okay. Now question number 24 is limit x tends to 1 f of x you have to find, where the function is given to be again two values. You have x square minus 1 when x is less than or equal to 1, and minus x square minus 1 when x is greater than 1. So we have to check for the left and right limit. So let's start with left hand limit, which is limit x tends to 1 minus f of x. Now 1 minus means it is to the left side of 1, that is less than 1. So you have to replace the function value with x square minus 1. So limit x tends to 1 x square minus 1. Now replace x with 1 which will give you 1 square minus 1, that is 0. Okay, so left hand limit is 0. Now right hand limit will be limit x tends to 1 plus f of x. Again the meaning is from the right side of 1. So it is greater than 1. So you have the function to be limit x tends to 1 replaced with minus x square minus 1. Now again replace the value of x with 1. What you will get? Minus 1 the whole square minus 1. That is minus of minus 1 the whole square. So you will get minus 1 which is minus 2. So you are getting right hand side as minus 2 and left hand side as 0. That means limit x tends to 1 minus f of x is not equal to limit x tends to 1 plus f of x. And when they are not equal, you will say that the limit does not exist, right? Therefore, limit x tends to 1 f of x does not exist. Okay. Now this can be done in another manner also, that is your h concept. And for left hand limit, when it is x tends to 1 minus, we will take it as limit h tends to 0 and the value of x that we will take as 1 minus h, and for right hand limit it is 1 plus h. In that manner also you will get the same result. I will just show you. Now if I am using the h type, that is limit left hand limit is equal to limit x tends to 1 minus f of x can be replaced with limit h tends to 0. Here you will choose your x to be less than 1, right? So it is 1 minus h less than 1. And replace what function you have to use. Since it is less than 1, you have to use this function, and in this function you have to replace your x with 1 minus h. So you will get limit h tends to 0, instead of x 1 minus h the whole square minus 1. Okay, so that you will get limit h tends to 0, 1 plus h square minus 2h minus 1. 1 get cancelled. Here you are getting limit h tends to 0, h square minus 2h, replacing h with 0, you will get 0 minus 0, 0 square minus 2 into 0, so that it is 0. So left hand limit you got it to be 0. Now going for right hand limit, you will write it as limit x tends to 1 plus f of x, and you have to replace this x with, that is you are putting x as 1 plus h. Then when you say that as x tends to 1, h will tends to 0. Here again you are putting x as 1 minus h. Okay, this is the difference. So limit x tends to 1 minus has been replaced with h. So you are getting limit h tends to 0. Again f of what will happen to x, you are replacing it with 1 plus h. Okay, and which function you will use in order to replace that? It is actually 1 plus, so greater than 1. So in this function you have to replace your x with 1 plus h. So you will get limit h tends to 0 minus of, instead of x you have 1 plus h the whole square minus 1. So limit h tends to 0 minus of 1 plus 2h plus h square minus 1, which is equal to limit h tends to 0 minus 1 minus 2h minus h square minus 1. Now when you see, this is limit h tends to 0 minus 2 minus 2h minus h square. Replacing the value of h, you will get minus 2 into 0 minus 0 square, which is minus 2. So you can see that the left hand limit and right hand limit are not equal here also. Okay, left hand limit is 0 and right hand limit is minus 2. So you can say the left hand limit is not equal to right hand limit. Therefore, the function's limit at x equal to 1, or you can say limit x tends to 1 f of x doesn't exist. So in either of the manner you can do the problem. Question number 25 is evaluate limit x tends to 0 f of x where f of x is equal to, again, two values at x not equal to 0 and x equal to 0. You have mod x by x when x is not equal to 0 and 0 when x is equal to 0. Okay, so let's start with left hand limit, which is limit x tends to, the point where you need to check is 0. So it is 0 minus f of x. Before that we should know something, that is mod x. What is modulus value? It is x when x is positive or equal to 0 and minus x when x is less than 0, right? So here we need to actually replace the mod x value accordingly. This is limit x tends to 0 Okay, I am just replacing the function value because this is the function value when x is not equal to 0, that is either it is less than 0 or greater than 0. The function value is this. After this we will replace it accordingly. If it is left hand limit, that is it is less than 0. When it is less than 0, you have to replace the mod x value with minus x by x, so that you will get this to be minus 1. So you are left with actually limit x tends to 0 minus 1. So that will not affect, because you don't have x will not affect, you don't have any x value, so the value is minus 1 for the left hand limit. Now for the right hand limit, limit x tends to 0 plus f of x will be limit x tends to 0 plus, again the same function, because it is greater than 0, that means it is not equal to 0. So mod x by x only. Now we are just replacing the value accordingly, as right hand limit means it is greater than 0. For greater than 0, the modulus function has the value as x, mod x equal to x. So it is x by x, which will give you limit x tends to 0, 1. Now again you don't have any x to be replaced, so the limit function value is 1. Therefore you are getting again left hand limit not equal to right hand limit. Hence limit x tends to 0 f of x doesn't exist. This can also be done in the other manner, that is h. So in the other way, how we will do is this limit x tends to 0 minus mod x by x. Now put x equal to 0 minus h. So you can see that as x tends to 0, so h tends to 0. Here x is also tending to 0. X tends to 0, h tends to 0. Now we are just replacing for the left hand limit, so that you will get limit h tends to 0. Instead of x, you are just replacing it with 0 minus h. So it is mod of 0 minus h divided by 0 minus h, which is equal to limit h tends to 0. Again mod of negative will give you negative of negative, which is becoming positive. Here it is minus h. Okay, so that this is limit h tends to 0. Mod of minus h will give you h only divided by minus h, so that h get cancelled and you are getting limit h tends to 0, 1 by minus 1 or minus 1. Now for right hand limit, again limit x tends to 0 plus you have f of x, which is equal to limit x tends to 0 plus mod x by x. Now we are just substituting x as 0 plus h, since it is right hand limit 0 plus h, and as x tends to 0, h will also tends to 0. Always h tends to 0 in any problem, but x value depends on what limit is given here. Okay, at which point you have to check that which will be replaced for x tends to. So your RHL will become limit h tends to 0. Instead of x, you have to replace it with 0 plus h divided by 0 plus h. So again this will give you h in the numerator divided by h, which is limit h tends to 0, 1, and the value will be 1 only. So again you can see left hand limit and right hand limit are not equal. Therefore limit x tends to 0 f of x does not exist. Okay. Question number 28 is, suppose f of x is equal to a plus bx when x is less than 1, 4 when x is equal to 1, and b minus ax when x is greater than 1, and if limit x tends to 1, f of x equal to f of 1. This is given. What are the possible values of a and b? So you have to find out the values of a and b when this condition is given and the function is given to be like this. Okay. Now since what is given is limit x tends to 1, f of x is equal to f of 1, the meaning is limit exists, and when limit exists, the left hand limit and right hand limit are equal. So instead of this I can just write limit x tends to 1 minus f of x is equal to limit x tends to 1 plus f of x equal to f of 1. And what will be f of 1? Just see, f of 1 means when x is equal to 1, what is the value of the function? It is 4. So f of 1 is 4. This much we have. Now from this you will get two equations actually, that is left hand limit is also equal to 1 and right hand limit equal to 1. So limit x tends to 1 minus f of x is equal to 4 and limit extends to 1 plus f of x is also equal to 4. Now our purpose is to get the value of a and b, means we will just find out what is the left hand limit and right hand limit, and you will get two equations in two unknowns, that is a and b. Solving them you will get the values of a and b. Okay, so starting with the first one, that is left hand limit. Limit x tends to 1 minus f of x is equal to limit x tends to 1 minus, which function you will use here? 1 minus means it is less than 1, so you have to replace f of x with a plus bx, right? So if I am using h concept, I will just put x as 1 minus h. Now when x tends to 1, h will tends to 0, right? So we are just replacing here, that is LHL will become limit h tends to 0 a plus b into replacing x with 1 minus h, which will give you limit h tends to 0 a plus b minus bh. Now just replace the value of h with 0, you will get a plus b. So that is left hand limit, and that will be equated to 4 afterwards. Okay, so let this be the equation in which we will substitute later. Now we will find out what is RHL, which is limit x tends to 1 plus f of x equal to limit x tends to 1 plus, and here x is greater than 1 means you have to replace with the function value as b minus ax. Now again, if I am substituting in terms of h, what I need to replace with is x is equal to 1 plus h. Now when x tends to 1, again h will tends to 0 here, right? So now replacing the value for the right hand limit, you will get limit h tends to 0, instead of x you have to replace it with 1 plus h, so that this is limit h tends to 0 b minus a minus ah. Now replace the value with 0 for h, you will get b minus a. So the left hand limit is a plus b and right hand limit is b minus a, and both are equal to 4. So you will get two equations in two unknowns. We will just solve them. So we have a plus b, substituting in 1, you will get a plus b as 4, and b minus a means it is minus a plus b as again 4. So adding the 2 will give you 2b is equal to 8 or b is equal to 4. Now replacing the value of b in either of the equations, you will get, see, you have a plus b equal to 4. So this is a plus 4 is equal to 4 means a is equal to 0. Therefore the values of a and b are 0 and 4 respectively. Okay. Question number 29 is, let a1, a2, a3, etc. an be fixed real numbers and define a function f of x is equal to x minus a1 into x minus a2 into etc. x minus an. What is limit x tends to a1 f of x? And for some a which is different from all these a1, a2, etc. an, you have to compute limit x tends to a f of x also. Okay, so let's start with the function which is f of x equal to x minus a1 into x minus a2 into etc. x minus an. Now in order to find out limit, we are just taking limit on both sides. Limit x tends to a1 f of x will be same as limit x tends to a1 of this product x minus a1 into x minus a2 into etc. x minus an. Okay, now what is the process? You have to replace x with a1 in the terms. So you will get a1 minus a1 into a1 minus a2 into etc. a1 minus an. Now I can see a1 minus a1 will give you 0. So 0 into, you are having all the other terms, a1 minus a2 etc. into a1 minus an. But since you have 0 into the product, you will get the answer to be 0 only. Okay. So that is limit x tends to a1 f of x. Its value is 0. Now we will compute what is limit x tends to a f of x. And they have said that a is different from all these numbers a1, a2 etc. an. Now applying limit to the function x minus a1 into x minus a2 into etc. x minus an replacing x with a, you will get a minus a1 into a minus a2 into etc. a minus an. Why? Product of the limit is equal to limit of the product. That's what we are applying here. So for each of the term you will have that limit to be given. Okay, limit x tends to a x minus a1 into limit x tends to a x minus a2 like that etc. Limit x tends to a x minus an. So we have just replaced the value here with a. The value of x has been replaced with the value of a, so that you are getting this answer. Okay. Question number 30 is, if f of x is equal to mod x plus 1 where x is less than 0, 0 when x is equal to 0 and mod x minus 1 when x is greater than 0, we have to find out the values of a for which the limit at that point exists, that is limit x tends to a f of x exists. That means we have to break the question into 3 parts, or the checking at the points into 3 parts. That is, here you can see the variation is occurring, that is the left side and right side of which term is giving you the different values for the function, that is 0. So at that point we need to check, and remaining for less than 0 and greater than 0. Okay, so here 3 cases arise. That is, when a is equal to 0, the value of a when it is 0, what will happen? Then when it is a value which is less than 0, that is negative value, and for a value which is greater than 0, positive value. Okay, at the point 0, less than 0, negative value, and positive value. So first we will move on for first case where we are taking a as 0. That means we are just checking whether limit x tends to a exists or limit x tends to 0 exists. Okay, so first left hand limit, that is LHL, equal to limit x tends to 0 minus f of x, which is equal to limit x tends to 0 minus means it is less than 0. So you have to replace the function value with mod x plus 1. Now what about mod x? Mod x, when it is less than 0, the function value, that is mod x value, is x when it is greater than 0 or equal to 0, and minus x when it is less than 0. So here our case is less than 0. That means mod x will be replaced with minus x plus 1 with the limit x tends to 0. Now we will replace x with 0, so that you will get 1 as the left hand limit. Now for right hand limit, limit x tends to 0 plus f of x is equal to limit x tends to 0. Again just see, x tends to 0 plus means it is from the right side of 0. This was from the left hand side. So from the right hand side of 0 you have to replace the function value with mod x minus 1. So it is mod x minus 1. Now again we know that mod x, when x is greater than a value which is greater than 0, the mod x value will become x. So limit x tends to 0, mod x, instead of mod x we will write x minus 1. And now we will replace x with 0, so that you are getting minus 1. That means left hand limit and right hand limit have different values here. Okay, one is 1 and the other one is minus 1. Therefore, left hand limit is not equal to right hand limit. That means limit at the point 0. That means when a is 0, the limit does not exist. Okay, or you can say limit x tends to a f of x doesn't exist when a is equal to 0. Now the next case is when a is less than 0. Case 2 is when a is less than 0, that is any value which is a negative quantity. Okay, for that what will be left hand limit? It will be limit x tends to, you can say a minus, we are not choosing a particular value, in general we are just saying this. Okay, this will be true for any value which is less than 0. Limit x tends to a minus f of x, and that will be replaced with, again a is less than 0 means you have to choose the function as this, right? This is mod x plus 1, and then replace here. Again mod x will give you minus x because it is less than 0. Okay, a value which is less than 0. So you are just taking it as limit x tends to a minus x plus 1. Now we will replace x with a. So you will get minus a plus 1. So this is the left hand limit. Again for right hand limit, limit x tends to a plus f of x, which is equal to limit x tends to a. Again the function value will be same because we have taken a as a quantity which is less than 0. So the function value is again mod x plus 1. Again when it is less than 0, mod function will be replaced with its negative, that is limit x tends to a minus x plus 1, and replacing with a you will get minus a plus 1. That means for the values which are negative or less than value, the function is not changing. That's why you are getting the left and right to be the same. Therefore LHL equal to RHL, which implies limit x tends to a f of s exist when a is less than 0. For any value, negative value, the limit exists. Now comes the third case, when a is greater than 0. Now for the third case, where a is greater than 0, you will have left hand limit is equal to limit x tends to a minus f of x, that is limit x tends to a. Again it is a quantity which is greater than 0. So for all those values which are greater than 0, the function is chosen to be mod x minus 1. So here I am just replacing f of x with mod x minus 1. Now again, since x is greater than 0, mod x will be replaced with x. So you will get limit x tends to a x minus 1. Now replace the value of x with a, so that you will get a minus 1. So that is your left hand limit. Now what happened to right hand limit is limit x tends to a plus f of x is equal to limit x tends to a. Again this meaning of this is also, it is a value which is a positive quantity and its left and right, so that both the values left side and right side of the positive numbers are greater than 0. So the function value is not changing, you are getting mod x minus 1 only here. Now since it is greater than 0, you have to replace the value with x, mod value with mod x is x, and now replace the value of x with a, so that it is a minus 1. Therefore you can see left hand limit is equal to right hand limit here also. That implies that limit x tends to a f of x exists for all those values which are greater than 0, for all those a values which are greater than 0. So what they have asked is for what values of a does the limit exist. So limit, hence from the three cases the conclusion is limit x tends to a f of x exists for all values except x a equal to 0. Okay, for all values except 0, right? That is when a equal to 0, the left is not equal to right. For remaining all the cases, you have the left side, that is LHL equal to RHL. Therefore limit exists for all other values except 0. Question number 31 is, if the function f of x satisfies limit x tends to 1 f of x minus 2 whole divided by x square minus 1 is equal to pi, evaluate limit x tends to 1 f of x. So you have to find out limit x tends to 1 f of x from the given thing. And what is given? Limit x tends to 1 f of x minus 2 divided by x square minus 1 is pi. So again we know that limit of a quotient is equal to quotient of the limit, so we can just separate the limit to the giving it to the numerator as well as the denominator separately, divided by limit x tends to 1 x square minus 1. And now what we are doing is we are just taking this denominator to the other side, because if we apply here this will become 0 here. So we are just taking this to the other side, that is limit x tends to 1 f of x minus 2 is equal to pi into limit x tends to 1 x square minus 1. Now applying the limit in the right hand side, you will get pi into 1 square minus 1, which is pi into 0, that is 0. So what you have got is limit x tends to 1 f of x minus 2 is equal to 0. Now we are just splitting again the limit, giving it to both the terms. You will get limit x tends to 1 f of x minus limit x tends to 1 2 is equal to 0, and you know that since this doesn't contain any x term, the value of this will be 2 itself. So limit x tends to 1 f of x minus 2 is equal to 0, or limit x tends to 1 f of x is equal to 2. So the value of the limit at x equal to 1 is 2. Next is question number 32. If f of x equal to mx square plus n when x is less than 0, nx plus m when it is lying between 0 and 1 including 0 and 1, and nx square plus m when x is greater than 1, for what integers m and n, that is for what value, integral values of m and n, does the limit, that is limit x tends to 0 f of x and limit x tends to 1 f of x exist. So we'll just go for first finding out how we are getting, or what condition you are getting for limit x tends to 0 f of x. Okay. So for that we will have limit x tends to 0 minus f of x, which is equal to limit x tends to 0, which value, less than 0. So the function value is mx square plus n. Now replace x with 0, you will get m into 0 square plus n, which is equal to n. Now for the right limit, so this is your LHL. For the right hand limit, you will get limit x tends to 0 plus f of x, limit x tends to 0, which value you need to substitute, greater than 0. Here it is greater than 0, so you can choose nx plus m as the function value and replace x with 0 here, so that you will get m. Now for the existence of this, what we need to get, left hand limit equal to right hand limit. Okay, so left hand limit equal to right hand limit will give you the limit value, right? Limit x tends to 0 f of x. Therefore what you are getting, left hand limit is n equal to m. So the condition for the existence of this is n equal to m. Okay, hence limit x tends to 0 f of x exists when n is equal to m. Okay, now we have to find out the other one, that is limit x tends to 1 f of x. Now for limit x tends to 1 f of x, again we will start with left hand limit, which is limit x tends to 1 minus f of x. Replacing the function value, what you will get, the meaning is it is less than 1. So less than 1 is also included here in the middle one. That means nx plus m should be instead of f of x. Okay, now we will just replace 1 for x, so that you will get n plus m as the left hand limit value. Now RHL is equal to limit x tends to 1 plus f of x, which is equal to limit x tends to 1. What will be the value? 1 plus means it is greater than 1, so this is the value which you need to replace. So that is nx square plus m. Again replace x with 1, so it is n into 1 square plus m, which is equal to again n plus m. So both value, again they should coincide if the limit exists. Therefore LHL equal to RHL will give you that existence of the limit at x equal to 1. That means you are getting n plus m is equal to n plus m. Hence you can say that for all integral values of n and m, the limit will exist. Okay, hence limit x tends to 1 f of x exist for all integral values. Integral values of m and n. So whatever be the integer value m and n are taking, that will exist because both have the same value. Okay, and for the other one, when n is equal to m, the limit will exist.